In this video, let's talk about normal buffers versus always on or AON buffers. So in normal buffers, we have an input pin, an output pin, a single power pin called V primary, and a ground pin. Always on buffers is exactly similar to normal buffers, except that instead of one power pin, we have two power pins, V primary and V secondary. And the reason we have two power pins in AON buffers is that even when the primary power supply is turned off, we have a secondary power or a backup power which is still supplied to this buffer through this secondary power pin, which keeps this buffer operational even when the primary power is turned off. So let's try to understand this using a simple example. So we have a partition here. Let's say that VDD is the always on power or the main power of this partition and it is never turned off. Now, let's say that we also have some logic in the design which can be powered off for power savings. So here we have a voltage area in the center of the partition where all the powered down logic will be placed. So let's say that in this voltage area, V off is the primary power supply. So this V off is basically just derived from our always on power, which is VDD, and it can be turned off through power switches as shown here. So in summary, we have two voltage areas in this design. Voltage area number one is where all the always on logic of the design will be placed, where power is never turned off. We have another voltage area, which is voltage area number two, where all the power down logic of the design will be placed. Let's say we have a always on signal which needs to physically pass through this voltage area number two. So in that case, any buffers we might need to add on this net inside voltage area 2 or the power down voltage area, they need to be always on buffers. Because if we use normal buffers, they will only have one power pin and that will be connected to V off inside this voltage area. So as soon as V off is turned off, those buffers will stop being operational and we will lose the signal which is being carried out by this net. So that is why we need to use always on buffers inside voltage area 2 so that even when V off is turned off, we have a secondary power pin which is connected to the always on power, which is VDD. So these buffers will remain operational, and even when V off is turned off, we won't have any signal integrity issues on this always on net which is passing through this power down voltage area. So that is why we need always on buffers while buffering such nets through an area where primary power can be turned off.